Okay, so here's the way it works with a tangent and cotangent graph. If we have a model of the form y equals a times the tangent of bx, or y equals a times the cotangent of bx, only a few things are different from the sine and cosine functions. For one thing, there is no amplitude, right? So what does a do for us? Well, a is going to change the stretch of our curve. So we're just going to think of this as a vertical stretch or shrink of the basic function vertically. Right? B is going to help us get our period. Now, for tangent and cotangent, the basic period is always found by taking pi and dividing it by b. This is different from our sine, cosine, secant, and cosecant. The period is always found by taking pi over b. So these rules are going to help us get the places that we look for our functions, asymptotes, and so on. All right, so what's that going to mean to us? Here's the way I would go through a graph for tangent. I've got y equals 2 times the tangent of 2x. A is equal to 2. B is equal to 2. But my period this time is going to change to being pi divided by b, so that's pi over 2. On my graph, how does that change things? Well, if the period is pi over 2, on one cycle, what's going to happen is this. Vertical asymptotes occur at wherever our period, we take half of our period to the left and half of our period to the right of 0. But that seems a little confusing. So let me help you out. There's a real easy way of doing it. Normally, our vertical asymptotes for tangent occur at negative pi over 2 and positive pi over 2. Right? We go back, we can see that that's the case right here, right? Vertical asymptotes negative pi over 2, positive pi over 2. But in this case, what we are going to do is we're going to say, well, what have we got for our function? This time we've got 2x. So 2x has to be set between negative pi over 2 and positive pi over 2. So I'm going to solve this inequality by multiplying both sides by 1/2. So that's going to give me vertical asymptote at negative pi over 4 and positive pi over 4. So on my function, when I graph it over here, I'm going to have my increments marked off so that one cycle will go ending at pi over 4, but starting at negative pi over 4. And so these will be the location of my vertical asymptotes. Okay, now if we're looking at this, we're saying, well, okay, what about that 2 that's in front? Well, if a is equal to 2, on my y-axis, I'm going to find 2. And I'm just going to mark this off by 2s, so that makes it even. Here's negative 2. So what happens at negative 2 and positive 2? Well, the nice thing is that, well, that value of a can be thought of really not as an amplitude, but as a way of finding those quarter points within one cycle of the graph of our tangent function. So for example, halfway between 0 and negative pi over 4 is negative pi over 8. Well, at negative pi over 8, which happens to be 1/4 of the full period, we're going to be at negative 2. At 0, we'll pass through 0. Halfway through the period off to the right is positive pi over 8. So we're going to go up to positive a at pi over 8. And our graph will come along, pass through our 3 points within one cycle, and then go back up along our vertical asymptote. And this is how you can get this picture relatively efficiently. Tangent is the only one that's really weird in this particular way, dealing with these vertical asymptotes. So you have to be very careful. And what I say is this: if you have y equals a times the tangent of bx, to find your vertical asymptotes, set bx between negative pi over 2 and positive pi over 2, and then solve for x. And that will get you your vertical asymptotes. Okay, one more example to come.